Our team is Group 10, Gallium Nitride Coffee Roaster. I'm Connor Tripp. I was in charge of the microcontroller aspects of the project, anything that had to do with embedded or embedded firmware. Clay Trotter was in charge of our mechanical aspects. Colin McHale was in charge of all of the integration, so he liaisoned with Clay Trotter on all of the things that were electrical that would need to be taken care of in a mechanical sense to make sure that he was on the right track. And finally, Andrew Seiler, who handled all of the hardware. So the problem that our project solves is there's a large niche group of people who want to roast small batches of coffee at home to their specification. They do this sort of as a hobby, and the group who approached us wanted to try and make this go more towards even a consumer market. So bringing this out of a niche and into the everyday homes of people who just drink coffee. Our solution is or our project provides a solution for that, in that it's a relatively inexpensive device compared to those that are currently on the market, and it also allows you to do up to a half pound of beans, which is just enough for a few days for one person, which means you can change up a lot. You can do all of the roasts that you would want to do in terms of customizability, darker roasts, lighter roasts, things like that. So the implementation is a fairly simple setup. All of the circuitry sits underneath, and then air flows up past the heating element in between, up through the chamber where the beans get heated by that hot air that's being blown, and then any chaff and exhaust hot air goes up into these buffers where the chaff gets collected and the hot air goes straight out the top. So definitely the hardest challenge for this project would be the gallium nitride integration. So figuring out how we were going to integrate that, what its role was, and then finally making mistakes in integration and learning along the way what it means to integrate a new device into a system. About halfway through the semester, we realized that we had our inductive load, our motors, on the wrong end of the GaN device. So this wouldn't have normally been a problem. It would have been poor design perhaps, but it wouldn't have caused a problem in a normal silicon device because the switching speed is slower. So the back EMF from the motor wouldn't have hurt it. Because GaN devices are so fast, at switching, the back EMF from the motor is much higher, which damaged the device. So we had to do a complete board redesign, and that caused some integration challenges later on in terms of timing. One of the most important parts of project management is time management, because if you can manage your time well and plan things ahead of time, any problems that come up, you have them accounted for.